Okay, hello everyone. Today our topic is more about resistance factors. Last time we focusing on the resistors formula like R equals to U over I, right? This is called Ohm's law, okay? So this is just a relationship between the potential difference, current, and the resistance, right? And now we are focusing on the resistance factors like the length, like the cross-sectional area, and also for the materials, okay? So one resistor is designed in the factory and its resistance is just a constant value, okay? So how we can design for the different kinds of resistors? Okay, so we can move into the first part, the effect of the length. So here you can find there are two materials, one is A, another is B. Sorry, the same material but two different substances, okay? So for A, you can find its length is just half of B, but the cross-section area and material is same to B, okay? And then you can just connecting into a circuit like this way, okay? And you'll find that using Ohm's law, and there's a very tight difference between resistor A and B, okay? And you'll find that the resistance A equals to a half of resistance B, okay? So based on the length of A equals to the length of B, you have a conclusion, right? That is a resistor's resistance just directly proportional to the length, right? So we can say that R is directly proportional to the L, okay? So here we can say, oh, that resistance is directly proportional to the length of the resistor, okay? So secondly, we are discussing about the effect of the area, and here you can find there B and C, also connecting the wire, using the wire and put the rod into the circuit, and you'll find that using Ohm's law, like using R equals to U over I, and you'll find that the resistance of B are the 2 times of resistance of C. And you'll find that here their length is the same and the material is the same, but for the like cross-section area, they're quite different, right? And you can say that, oh, RC equals to, sorry, the cross-sectional area of AC equals to 2 times of AB, okay? So we can find here that is quite different, right? Because area increases, but resistance will decreases. So we can say here, oh, that they have a inversely proportional for the effect of area, right? So here we can say R is the inversely proportional to the area, okay? But there are the second quantities for the resistor, okay? And then maybe we can use this to form the formula like this one, R equals to rho times L over area. And the rho means like a kind of conductivity. If you are the metals or like you are the materials that is very easy to conduct, the rho is very small. And if you're like a very hard object to conduct electricity, we can say that the rho is very big. Okay, like PVC or like the plastic, like even other kind of material that is very hard to conduct electricity. Okay, so here we can say L is here and area is below, right? Because here when the length of the resistor increases, the total resistance increase, and when area of the like the resistor increases and the total resistance decreases. Okay, so we can say here the formula is R equals to rho L over area. Okay, so like you can find there are two kinds of materials. One is area A and another is area 4A. And you'll find that basic difference is on their diameter. So if a problem asking you that, oh, they are the same length and they're the same materials, how about their resistance difference? You can find that, oh, because of the diameter is 2 times, so their cross-section area is 4 times, right? Using the formula of a circle, area equals to pi r squared. So we can say, oh, here the area is 4A. So we can say, oh, here for this one is using the formula R equals to rho L over the area, right? And here the L is the same, but the area is 4 times. So this material is 1/4 of this material's resistance, right? So here we can say, oh, here the area is directly proportional to the diameter square, okay? So let's move into the exercise like here, just trying to consider how to calculate the var y using the basic properties and the data in var x, please. Okay, I guess it's not very difficult, right? So here you can using the formula like var x, you can using R equals to rho L over area, right? So here the R resistance is 2, and here rho is rho, and L is 1, and for cross area is 3, right? So you can write down that rho equals to 6. And for y over y, you can also use the formula that R equals to rho L over area. And here is 6 times, like the length is 1.3, and the cross-sectional area is 0.3, right? So maybe the answer right here, sorry, I guess R equals to rho L over area. The length is 1. Oh, sorry. Here the area is 0.4. Okay. So here is 0.8. And here is 0.8 times 1.3 over 0.3, right? So here we can find the final answer is about 2.1, right? Okay. Oh, sorry, 3.5, right? Okay. So we choose D. Okay. So here's today's our lesson. So see you next week. Bye.